Good afternoon, everyone. Once again, I bid you a very warm welcome. I think in some places, the welcome would not be that warm. Here in Durban, it's 14 degrees centigrade, and I presume that the temperatures elsewhere are even worse. But be that as it may, I still bid you a warm welcome to this one-off session where we are going to discuss the 2022 Junior SAMO, the South African Mathematics Olympiad paper that you wrote a few weeks ago. And I'm sure that you would be quite anxious to know how well you did. So for that reason, we thought that it would be nice if those people who want to know the results, at least they can find out how many they got right, if we can go through these problems. So I want to welcome all of you. A special word of welcome to my good friend, Patrick Reseberta, who is the project manager of South African Maths Foundation. And it is through his goodwill that his and others in the foundation that we are privileged to have this session. Okay, now with those few remarks, let me get the screen going. Always have some difficulty with this. What's going on here? Just one moment. Okay, let's try to see whether we can make some progress here. I want to share the screen. Okay, so we're on our way, I think. All right, so let's get on to the very first problem. First, I need to get this out of the way here. All right, so the very first problem is a rather simple problem. It's a problem in geometry, and you have a flag-like picture here in which three angles are given, and there is one of the angles is an unknown, the x, and you are asked to calculate it. All right, for this, we need to know a few things. One of the things that we need to know is that the angles of a quadrilateral always add up to 360 degrees. So a quadrilateral, this is a quadrilateral, a four-sided figure. If you add the four angles, you'll always get 360. With a triangle, it's 180, but with the quadrilateral, it's 360. And so we know two angles. In fact, we know three angles, because if this is 60, this is a straight line, this will have to be 120. So now we have no three angles. So, and the sum of all of them is 360. And we have an equation immediately, because x plus the other three, which I can see is 280 degrees, 170 is equal to 360 degrees. Just one moment, please. So that gives you x equal to 80 degrees. See, one of the big things about problem solving is getting an equation. And here the equation is very clear, right? The sum of the angles of a quadrilateral is 360 degrees. Okay, so the next one, question 2. So the answer to this problem is 80 degrees, the first problem. Okay, let's get on to question 2. In how many ways can you arrange the letters AAYYY so that the sequence reads the same backwards and forwards? All right, now, how does one go around doing this? Well, it's a 5-letter word, so it'll be useful to know what the middle one is. All right, so you've got 5 letters at least, the middle one. And the middle one can only be Y, it can't be A, because there's only one A left. And you can't be in the middle because you need to read it the same backwards and forwards. So the middle one will have to be Y. And so you've got those, and the other letters will have to be AA and YY. You have to place them somewhere. All right, so where do we want to place the A? We can place the A here, right in the beginning, in which case the A will have to go in the end because you're reading it backwards and forwards. So the 2 A's are placed, and then the 2 Y's go in here. So that is one of the ways where this reads the same as backwards and forwards. So if you put A at the beginning, there's only one answer. Okay, so let's try to put Y in the beginning and see what happens. Remember, Y is the middle. If you put a Y here, okay, then Y also goes here. So now all the Y's have gone. There are only 3 Y's. So you've got no choice but to put the 2 A's here. And again, this reads backwards and forwards. And this argument says there are only 2. For the first letter, an A, there's only 1, and the same with Y. So the question says, in how many ways can you arrange it? And the answer is there are only 2 ways. Okay, so that takes us to the third question. The third question says A and B are whole numbers, and A times B is 200. If neither A nor B is divisible by 10, what is the value of A plus B? So that's the question. So you know when you multiply the 2 numbers, you're going to get 200. That's the first thing. And you know that neither of these 2 numbers is divisible by 10, which is the same as saying neither of the 2 numbers ends in 0. All right. Okay, so let's look at the factors of 200, because these are factors. So you're looking at 2 times 100 is a possibility, but you can eliminate that because one of them ends in 0. Or you can try 5, that's the next one, 5 times 40. You can eliminate that as well. And the next one is 10. No, wait a minute. 8. 8 is another one. 8 goes into this exactly. 25. Okay, so this is allowed. Okay, and if you want to go on a little bit, the next one is 10. And we can eliminate that, and so on. Okay, so all the others have got a 10 in them. So the only one which is not the only pair where neither is divisible by 10 is this. So this has to be A and B. So A plus B is 33. Doesn't matter which is A, which is B. We are looking at the sum of these 2, and the sum of these 2 is only one answer. So the answer to question 3 is 33. Okay, now we go on to question 4. Question 4 says, which whole number is closest in value to this? Well, it's a problem on approximation. Okay, so you need to approximate all these objects in this question. You need to approximate them with integers, and that's very easy because this is almost 1.99. So it is approximate like that. The square root of 110, the closest integer is square root of 100, which is 10. At the bottom, this is 5.021, and the closest integer to that is 5. So the answer is 2. 1 squared is 1. And 5 goes into 10 2 times. Okay, so that was easy enough. So you can see the first few questions are warm-up questions. You don't require too much of thought in them. Now we're getting on to some problematic questions. Right. A quarter of the square root of a number is 1. What is the number? Right. Now, you have to read this thing and understand it. A quarter of some number is 1. So, some number being the square root. So, the square root of the number must be, if the quarter of that number is 1, so that number must have been 4. But this is the square root of the number. So if this is the square root of the number must be 4 squared, because 4 is the square root of 4 squared, which is 16. Right? So it's a matter of reading the question and understanding it, and then drawing your conclusions. So we move on to question 6. So question 6 says, a rectangle is cut in half to form 2 squares. All right, so that's a good indication of what that rectangle is. Let's draw a rectangle, and you want to cut it in half to make 2 squares. Okay. Each of these squares has perimeter 40. So if you take the perimeter of the squares, if you go all around it, it's 40. And in the square, of course, all the sides are the same. So you add these 4 equal numbers to get 40. So each of them must have been 10. So all these sides are 10. Now this is cut in half, so these squares are exactly the same. So the question is, what is the perimeter of the original rectangle? So you need to work out what the boundary length is. And it's clear, you can just simply add up all these 6 tens and you'll get 60. The units are given centimeters. So there are 10 sixes here. I mean 6 tens. So that's straightforward. The important thing is understanding that the rectangle is cut in half. So you have to draw the rectangle nicely so that you can get 2 squares out of them. Once you do that, then the rest of it is easy. on. Okay, so now we go on to question 7 now, which says the following. Oh, no, this is question 7. A bucket of water weighs 16 kilograms when completely full. All right, let's just draw a bucket. So when it's completely full, it's got 16, it weighs 16 kgs. So the weight of the entire bucket together with the water is 16 kgs. Now when half the water is poured out, so just the water is poured out, the bucket weighs 11 kilograms. So what conclusion can you make from that? Well, let's draw a neat picture. Not so neat. Sorry, I can spend the time in better ways, but might as well. So now half of it is poured out. And now the bucket weighs 11. So what does it mean? The weight has dropped down by 5 kgs, right? So what weighs 5 kgs? It's the water that has been dropped out. So half the water weighs 5 kgs. The weight is reduced by 5 from 16 to 11. And so the reduction is as a result of the water being dropped off. And that's half the water. So the full water would have been 10. Full bucket, the water would be 10. So in this scenario here, the water is 10. So that tells you straight away that the weight of the bucket is 6 kgs. Right? So what is the weight of the bucket in kilograms when empty? So that's the answer. Right? So if you remove the 10 kgs of water from the 16 kgs, you'll be left with the empty bucket. So it's 16 minus 10. Okay, so that takes us to the next problem. The next problem says 3 identical isosceles triangles. Identical. They're exactly the same. Another word for identical is congruent. In mathematics, the word congruent is used to represent the word identical. So anyway, so these 3 identical triangles fit snugly into a square. So you can see, so these are all just clones of each other, identical. Now, 2 of the angles have edges in common. Okay, you can see the diagram. What is the size and degrees of the shaded angle? So you need to work out this shaded angle here. All right. So how do we do this? We say, well, let's see now. I don't know this angle, but I know the full angle. That's 90. So I can calculate this angle if I know this angle here. All right. So do I know those? Do I know that angle? Well, these are these are all identical. So it means that this is a square here. So so they're identical. So these angles will be the same also, because they are identical, you see. And that would mean that these sides must be equal, like that, as you can see. All right. Because all that happens is you just take this original triangle and rotate it through the dot angle, and you'll get to this, and rotate this to get to this. So you will see that these sides will have to be the same. Okay. So bearing that in mind, what is the dot? We don't know what this is, but now we know that this has to be the same, because this is an isosceles triangle. Two sides are equal. Okay, so these two are equal. Now, then we can calculate them provided we know what this is. But three of these give you 90. They all are equal because this triangle is identical. So each one of them must have been 30. Right? So this angle here is 30 degrees, but this is isosceles. But whatever the case may be, when you add these two, they must be 150, because all three angles sum to 180. So if one of them is 30, these two add up to 150, but they are equal because this is an isosceles triangle. So, and in an isosceles triangle, the sides, the angles opposite the equal sides are equal. So these angles are equal. They add up to 150. So each must be 75. So if they are 75, the whole thing is 90. As I said, if you know what this is, then you can calculate what the other one is. So it's 90 minus 75. Okay. So what's important is that you have to explain why these two angles are equal here. See, because these triangles are identical. All right, so let's just get on. If you want to have a really rigorous proof of why these sides are equal, you can do it like this. You can say, well, this is equal to this. And because these are exactly the same, these, you see, it's not given that these two insides are equal to the sides. It's not given. So if you really want to know, then you can say, well, these are identical. So therefore, these angles will be the same. This angle here, they're congruent, you see. Right. So now, because these two triangles are congruent, it means that the third side will be equal like that. See? But then it now means that this angle here is 30 degrees. So all of them are 30 degrees. And then after that, you can do the rest. Okay, so let's get on to the next problem. We didn't have to do all what I just did towards the end, because you can prove it intuitively, by intuition. But if we were to write out the proof, then you will have to know why we are saying something, okay? All right, the next question, question 9, says that the total surface area of a single cube is 12 centimeters squared. So when you got a single cube, these cubes here, the total surface area if I draw a cube there like that, now a cube has got 6 sides, all identical, right? All of them are squares. It's nice to know the properties of a cube. You got 6 faces. You call these the faces, right? And these lines here are called the edges. It's got 12 edges. You got 4 on the top, 4 at the bottom, and 4 all around, right? And you got vertices. And you got 4 vertices at the top and 4 vertices at the bottom. These are the corners. So 8 vertices. So every cube has got those kinds of properties. But whatever it is, you've got 6 faces, all of them are equal, and the total surface area is the sum of those 6 faces, all of them which are identical. So each face will be 2. So the area of each of those faces is 2. So what we're looking at here, this face here is 2, that face is there 2, and so on. And now they are put next to each other from end to end like this, right? And the question is, what is the total surface area of this thing? The whole thing is attached now. 100 cubes are placed next to each other. What is the total surface area? Well, you got 100 of these. So this total surface area, you got 100 twos here. But you got also another 100 twos at the top, another 100 twos behind, and another 100 twos at the bottom. Right? That's the total surface area. So there are 4 sides all around. So you've got 2 times 100 gives you just the total surface area of what we see here, but you must multiply that by 4 because you are adding the top, the back, and the bottom as well, and they're all out 200. And then you still need to add these 2 guys on the side here, which we haven't added. The other ones, they're all sealed because they're all sealed together. They're placed like this way. They don't form part of the surface, but the ends form the surface. And so there's another 2 here, and there's a 2 on that side. So that gives you plus 2 plus 2. That gives you 804. So that's the total surface area of this shape. Okay. The answer is 804. Square centimeters. Area is always square centimeters. So that's the answer. Okay, so the next problem is going to question 10. The diagram shows a square subdivided into 3 triangles, as you can see. Now this is a square, and then you draw a diagonal, and then one of those triangles is split into 2 ways. Okay. The ratio of the area of triangle C to triangle A is 1:5. So what does it mean? It means that this area to the A, the full area, the ratio is 1:5. So in other words, if this area here is X, if this area here is X square units, they say square units here, right? So if this area here is X, then the ratio of this area to this is 1:5. So if this is X, then this area here is 5X, this triangle. But you got a square, and this triangle here, this diagonal, splits the square up into two equal triangles, as you can see. So the area of this entire thing is 5X. So the area of this entire thing must be 4X, 5X also, right? The area of this triangle here. So the area of this triangle, area of this whole triangle is also 5X. We already know that that is X. So it means that this other part must be 4X. Yeah. But they do tell you that the area of triangle A is 10 square units. So A, the 5X, that's the area of A, and that is equal to 10. They tell you that. So therefore, that gives you what the value of X is. So X is equal to 2. And so the area of triangle B will have to be 4X, which is 8, 4 times 2. So the important thing here is the ratio. We don't know what this area is, so give it a name, and then you can eventually try to get an equation. The equation is very easy here. Once this is X, that is 5X, and 5X is equal to 10, because you are told that the area of A is 10. Okay, and then bearing in mind that this diagonal cuts. Actually, in any parallelogram, the diagonal always cuts the parallelogram into two equal areas. As long as the opposite sides are parallel, then you will always have the situation that this is a parallelogram, a figure with opposite sides parallel. Right? And then when you draw the diagonal, in fact, when you draw the diagonal, these two triangles are actually congruent. A diagonal of a parallelogram breaks the palm up into two identical triangles. So therefore, they will have the same area. So particularly in particular, the square is a parallelogram. So this can work. All right, so we now go into question 12. So the answer to this last question was 8. That's the area of B. 4X, we had, and X was 2. All right, question 12, they say 10 soccer teams play in a league. Each team plays every other team once during a season. How many soccer matches are there in a season? So you want to know how many soccer matches there are. You've got 10 teams. Let's say the teams are A, B, C, D, E, F, G, H. So I, J. So suppose you give names to those teams, right? Now they play each other. Each team plays every other team. Like for instance, A will play B, It'll also play C, A will play D, A will play E, F, G, H, I, and J, right? And here, there are only 9. There are 9 here. So when A plays all these, there are 9 such games. But now let's go on to B. We can't include A now because we've finished with all A's games. So if you work with B, you'll have, the B will play C and play D, E, B, F, B, G, B, H, B, I, B, J. And here you will see you've got 8 matches here. Right? Once you discard A, then you got 8 matches for B. And if you try C, you'll see that you got 7 matches because now you must discard both A and B. Those are already counted. So for C, you will have 7 matches. For D, for E, for F, for G, F, G, 7, 6, 5, 4, 3, G, like that. So the number of games is altogether is you simply have to add all these. 1 plus 2 plus 3 all the way up to 9. That's the number of games. This is a symbol for number of games. When you add all these numbers, 1 plus 2 plus 3, you'll get 45. Actually, you get 9 times 10 divided by 2. 2 goes into 10 5 times. Okay, now why is that so? Because it's a very important formula which all of you should know, that when you add the first natural numbers, n natural numbers, the answer is n times the one immediately after that divided by 2. Right? The number of numbers you're adding, n, increase it by 1 and divide by 2. That's how I got 9 times 10 divided by 2. So that's a very important formula that you have to know. Or if you got 10 soccer matches, if you put 10 in front, then it's 10 times 9 divided by 2. So the number of matches is that times n minus 1 divided by 2, you see? Because the answer is 9 times 10. Actually, it's like choosing 2 teams. The problem is really, how many ways can you choose 2 teams from 10? Because what we are doing is, we're choosing all the possible pairs of teams to create a match. Every team has to play every other team. So you pick all the possible pairs. And those who attended my class the last time know that the number of ways of selecting whatever, it need not be teams, it could be marigolds, 2 objects from n objects. The very important formula, right? Here you see it. We're selecting 2 from 10, and the answer was 10 times 9 divided by 2. So it will always be n times the one below that, which is n minus 1 over 2. It's a very, very important fact. And I told you to remember it, those of you who were in my class. So we could have done it like that. We could have said, well, the number of games is just the the same as the number of ways in which you can select 2 teams from 10, and that is 10 times 9 over 2, and the answer is 45. You could have written it in a matter of a few seconds instead of going through this long, tedious process, right? So anyway, I hope you learned something from this little discussion, because it's a very important fact that if you want to pick 2 objects from n objects, then the answer is n into n minus 1 over 2. Right? But when you're adding all the natural numbers up to n, then the sum is n into n plus 1 divided by 2. So there's a difference between these 2 things. All right, so let's get on to problem number 13. So the answer to this last problem was 45. The answer is 45. Okay, that's the number of games. Question 13. The size of the 4 angles in a quadrilateral are in the ratio 1:2:3:4. Now, ratios are very, very important. The most important thing about ratios is that if you are given a ratio, here in this, it's 4 objects, 1:2:3:4. You can multiply all these numbers by the same number, like for instance, 10:20:30:40, right? And it's in the same ratio. Ratios, you can take out common factors and you can simplify them. See? When you have a ratio of only 2 objects, right? Like for instance, 7:9. This is the same as 14:18, the same as 21:27. Because every one of them, you can just simplify it. You can just take out the 2 and you come to that, take out the 3 and you come to that, and so on. So in a ratio, we don't know what the actual numbers are. That is the point. But we do know that if you multiply all the numbers by the same number, you'll get the same ratio. So the angles are, I can write down straight away, the angles are not 1, 2, 3, 4. The angles are x, 2x, 3x, and 4x. It's some multiple, the same multiple of all these 4 numbers. So let that multiple be x. Like here in this case, the x was 2. In this case, the x is 3. And here the x here was 10. So you multiply by the same number right throughout. So then that will give you exactly what the angles are. Right? But you also know that when you add the 4 angles in a quadrilateral, we've seen this earlier, you're going to get 360 degrees. So you already know these are the angles. So when you add them, you're going to get 360 degrees. Because the angles of a quadrilateral add up to 480 degrees. 360. So you got the 4 angles are x, 2x, 3x, and 4x. And so you got an equation. The moment you got an equation, then you can solve for your unknown. In this case, you got 10x is equal to 360. So therefore, x will have to be 360 divided by 10. And that is 36 degrees. Remember, these are x degrees. Okay, but the problem was not to find x degrees. The question was what? Always go back to the question. What is the size of the largest angle? So the largest of these angles is 4x that you can see. So the answer to the question is it's 4x, and we just calculated x. So that is 4 times 36 degrees. When you work that out, it's 144 degrees. So the largest is 144 degrees, and that's what we are asked. Find the largest of these angles. So that's the answer to question 13. The answer to question 13 is 144 degrees. Okay, so the next problem now is how many integers between 1000 and 2000 have exactly 3 1. Exactly 3 1 digits in them. Well, I understand by that you have exactly 3. So example of such a number is 1181. It's between 1000 and 2000, and it's got exactly 3 ones in it. All right, so you need to find how many of them have got exactly 3 ones. All right, now all these numbers, they look like this. They start with 1, and then you got 3 other numbers, right? They must start with 1 because they are between 1000 and 2000. So the numbers we're looking for, our numbers look like 1xx, like that. That's what it looks like. But we also know that 3 of them are 1s. Okay, so what we can do now is, okay, one of the numbers is left out of these 4 numbers. So let's leave the number out. So suppose we leave the second digit out, but then you need to have 2 1s. The first one is always 1. So you need only 2 more 1s. So if you leave the second digit out, you can get that, or you can leave the third digit out and you get that. And if you leave the fourth digit out, you get that. So our numbers look like that. All these numbers have got 3 1s in it, but you must make sure that this number here is not 1. Otherwise, you've got 4 1s. So the question is, what must you put inside here? It's 1 blank 1 1. So there are quite a few possibilities for this, but 1 is not one of them. So you can put 0, or you can put 2, or 3, or 4, or 5, or 6, or 7, or 8, or 9. You can put any one of these. How many numbers have we got here? You got 10 numbers, but the 1 is missing. So there are 9 such numbers, which look like this. So it's 1011, 1211, 1311, 1411, and so on. So 9 such numbers. Likewise, you have even this too. If you argue this out, you're going to get another 9 there. And here too, you get 9. Because in each case, you don't put the 1, but you can put any one of these. So there are 9 numbers which look like that, with the second digit missing. 9 digit is not a 1. And 9 numbers with the third digit is not a 1. And 9 numbers with the fourth digit is not a 1. So altogether, that takes care of everything. Altogether, you got 27. 9 plus 9 plus 9. All of them start with 1. So one of them is already there, one of the 1s. So it's just a matter of counting how many others there are. So the answer to that question is 27. That's problem number 14. Okay, we got on to problem number 15 now. Okay, now problem number 15 says, I chose red at some point and I'm continuing to use red. I'm going to go back to black. So A over B is 6, B over C is a quarter, and A plus C is 30. So you got three unknowns here. You got A, B, and C, and you're asked to calculate one of the unknowns, namely B. Okay, let's write this. This is an equation. Let's write it decently. By decent, I mean don't have any fractions. So you multiply by B on both sides, and that'll kill the fractions. And the same thing here, you have to multiply by, actually we should multiply by 4C to kill both the fractions. So when you multiply by C here, you get 4B. If you multiply this by 4C, and if you multiply it by 4C, you get C. Or if you like, you can cross multiply. 4 times B is equal to 1 times C. Right? Same thing. So now you've got two equations which are looking very much more decent. And you've got A plus C is 30. Now you got C is 4B, you see. So A plus C, you can get both of them in terms of B. The A is 6B and C is 4B. And that gives you 30. So that's an equation. Because we know A plus C is 30. So what I do is I calculate A plus C from my two equations. And I got that. But now you got a simple equation. 10B is equal to 30. So B must be 3. Oh, that's exactly what we wanted. Determine the value of B. So the answer to question 15 is that the value of B is 3. Excuse me, please. All right, so the next problem is, we're going on to problem 16 now. Problem 16. What does problem 16 say? It says that the integers P and Q, all right, so these are integers. 1, 2, 3, 4. Actually, it could be negative as well. Okay, the integers P and Q are such that P divided by Q so P divided by Q, I'm going to put it down like this. P divided by Q is equal to 3.75. Okay, now this is a fraction here, and this is a decimal. So maybe we should convert both to fractions. 0.75 is 3/4. Okay, and that's a mixed fraction. Let's make it 15/4. So we got P over Q is actually equal to 15/4. You may think that therefore P is equal to 15 and Q is 4. which is fine. But they tell you that when P is divided by Q, the remainder is 9. Now, if you said P was 15 and Q is 4, when you divide 15 by 4, it goes into 3 times, and the remainder is 3, not 9. Right, so what went wrong? What went wrong is that 15 over 4, there are many ways in which you can write 15 over 4. It could be, as we said earlier on with ratios, so you can multiply that by 2, you can get that. This is still the same thing, P over Q is 15 over 4, if you simplify this. Here, when you divide 30 by 8, 8 goes into 33 times 24. The remainder is 6. All right, so let's go on. If you multiply 15 over 4 by 3, you get 45 over 12. And in this case, 12 goes into 45, 3 times 36, and the remainder is 9. So this is what we are looking for, right? So P over Q is still 15 over 4 if you simplify this, right? Which is 3,75. But when you divide 45 by 12, you're going to get 3, remainder 9. So what's the value of P? P is just the numerator in this problem, P over Q. So it must be 45. Okay, so that's the answer to question 16. Answer to question 16 is 45. Now, in a group of 6 pupils, 2 have brown eyes. I couldn't suppress a laugh, a smile when I saw this. These 6 pupils could be the pupils within the eyes of these 2 students. So if you have 3 people, 3 people have got 6 pupils actually. Each has got 2 pupils. Anyway, there's a bad choice of words here. In a group of 6 pupils, 2 learners, maybe we should say learners, then it's no difficulty. 2 have brown eyes, 2 have blue eyes, and 2 have green eyes. Right. Now let's just identify them. You got, let's draw like a thing like this, 6 pupils. So 2 have got called green, brown. Oh, might as well. Brown. And blue. Oh, bad choice. Let's call it small b. So this is the blue. It's the brown and green. Okay, so you have 2 of them have got that, and 2 have got. These are the eyes, by the way. So let's not talk about 2 eyes. That's rather silly. So we can say there are 2 people who got green eyes, 2 people got brown eyes, and 2 people got blue eyes. Right. Now, you want to choose a group of 3 people such that none of them has the same color. But there are 6 pupils. You want to choose 3 of them so that none of them have got the same eye color. So if I choose one from here, I can't choose the other, so I must choose exactly one. So here too, I must choose one. And here too, I must choose one. Right. The question is now, in how many ways can you choose this group? So if you choose, these are 2 different people. So you can't put GG. We have to make it maybe G1 and G2. This guy, this is the first guy who's got green eyes, second guy. So there are two people here in each case. So I want to choose one from each. Like for instance, I can choose G2 and B1 and small b2. One from here, one from here, one from here. So how many ways can you do this? It's you have to look at all possibilities like this. Well, maybe we can do it systematically so that we can count everything. So I'll say, okay, let me insist that G1 is chosen. Right. Now from the other guys, I can have B1 and small b1, B1 and small b2, right? I can insist on B1 being one of them, or I can insist that B2 is one of them, and then B2 or the other. So these are the only possibilities that you have of choosing one from here and one from there. Right? So there are 4 with G1. And likewise, if I chose G2, I'm going to have another 4 here. Right. So the answer must be, if the only 2 ways you can choose the green. So for this fellow, there's 4 choices. For that, there are 4 choices. So the answer must be 8. Answer is 8. Actually, there is a general way of doing this thing. I'm not going to go into discussion with that. I might have done it with the earlier classes. The general way is essentially what you want to do is to fill 3 boxes. Right? You got the green and the blue and the small blue. Now this box can be filled in 2 ways. You can either have G1 or G2, and this one here also 2 ways, and this one here is also 2 ways. Because you could have, you know, the first guy with the blue eyes and the second guy with the blue eyes. Right? And to find out the number of ways, there's a very simple way of doing it. You find out how many ways each one can be done, and then multiply. Two times 2. And you see it's the same answer. Right? So the easy way is, and how many ways can you fill the first box? How many ways can you fill the second box? How many ways can you fill the third box? And then if you want to know how many ways you can fill all the 3 boxes together, like this, the way we have done, then you simply multiply the whole lot and you can get to the answer. So the answer to question 17 is 8. Okay, we're going to question 18 now. This question here, you're asked to determine the area of quadrilateral ABCD. Okay, now you can see this quadrilateral has got a right angle here, and you got the 4 sides, 3, 4, 5, 6. And you might say, hey, I don't know the formula for a area of a quadrilateral. Nobody taught us that. We know the area of a triangle is half base times height, but quadrilateral, we don't know that. We were not taught this, not in the syllabus. So you will find some reason to say why you cannot do this problem. But I suggest to you, you can do it with your information on triangles alone. What you can do is you can split this quadrilateral into two triangles by connecting one of the diagonals. And I've deliberately chosen this diagonal here because I know how to find the area of a right angle triangle. Area of a right triangle, we need to find the area. So I draw this and I can work out the area of this right angle triangle. Half base times height. 4 times 3 is 12, divided by 2, and the answer is 6. So the area of this thing here is half base, which is 2 times 3, which is 6. Now the question is, what is the, you can find the area of the entire quadrilateral, but you need to know the area of this, and you don't know the height. You got two bases, but you don't know the height. So you don't have a formula for this. But for the time being, because it's a right angle triangle, I can calculate the third side. You got 3, 4, so the third side will be 5. Let me just separate this thing. So we'll just say the area of this is 6. Right, so the Pythagoras' theorem tells you that if you got two sides are 3 and 4, then the next side would be 5. 3 squared plus 4 squared, square root of 25. So now you've got a little bit more information. You've got 5, 5, 6. We still don't know the area of this triangle because we don't have the height. But the important thing is that this is an isosceles triangle, you see. And you must always make a habit, even when you go all the way up to grade 12, make a habit of whenever you have an isosceles triangle, a very important thing happens with the isosceles triangle. You can split an isosceles triangle right down the middle to get two right angle triangles. See, from here, if you drop a perpendicular, right, then you will have two identical triangles. Why identical? Because they are congruent. You can see you can see clearly these two. Well, you got 5, 5. You got a common side, and you got 90 degrees. So if you look for the reasons for the congruency, you got side, side, common, 90 degrees. So you got two sides and an angle, but the angle is not included, unfortunately, because the angle included between these two sides is that one. But the other reason for congruency comes into focus here, namely right angle, hypotenuse on that side. So in short, these two triangles are congruent, and I've just very briskly told you why, right? So therefore, these two must be equal here. This will be 3, this will be 3. Okay. And once again, you got 5 right angle triangle, 5 and 3. So this must be 4, that height. 5, 3, 4. And now you have the height of this isosceles triangle. It's 4. So the area of this is half base, which is half of 6 times the height. That gives you 12. 6 plus 24 divided by 2. So the area of this triangle here is 12. The area of this is 6. So the answer is 12 plus 6. Square units. Units are not given. So the idea here was to split the quadrilateral into two. One of them is a right angle triangle, and the other one turns out to be isosceles. And I told you a method of finding the area of an isosceles triangle. Don't forget that. Whenever you got an isosceles triangle and you want to find the area, split it down the middle, as we have done, and you'll get two right-angle triangles. And you know how to find the area of a right-angle triangle, so that's not a problem. I could have found the area of each of the right-angle triangles. As we saw there, this part here is 6, and this is 6, and they add up to 12. You could have done it like that. The area of a 3, 4, 5 triangle is 6. Okay, but if you wanted to use the formula, you're quite welcome to do so. Okay, so we go into question 19 now, which says, so the answer to the last problem was 18. That's the answer. Question 19. A multiple choice test consists of 50 questions. Each correct answer is worth 2 marks. And 1 mark is deducted for each incorrect answer. So sometimes people, if they don't know the answer, they just put a blank because they don't want to take a chance and lose a mark. All right, so they say 1 mark is deducted for each incorrect answer. A pupil scores 55 marks for the test, and no question was left unanswered. So this guy, he answered every question. He wasn't scared that some of them may be wrong and he's going to lose a mark, but he realizes that if he hits the right choice, he'll get 2 marks. And if he hits the wrong one, he'll lose 1 mark. So it might be better to take a guess and go for it. Now the question is, how many questions were answered correctly? So this is an interesting question. So you got 50 questions altogether. Some of them were correct and some of them were incorrect. So let's just draw a little diagram like this to say you got the correct ones and the wrong ones. And he scored 55 marks altogether. The only thing we don't know is how many correct. The question is how many were answered correctly. So if we say, so we don't know how many questions were answered correctly. So let's call it X. Suppose, and try to get an equation. Suppose X questions were answered correctly. And now we try to work towards an equation involving X so we can solve for it. That's a question. We were asked how many questions were answered correctly. If I know X, that is the answer. Okay, so in other words, you are splitting this into 2 parts here now. The X here. X of them were correct. And so how many were incorrect? He answered every one of them. There were 50 questions. So you would have had 50 minus X incorrect. That word hardly looks like. This word is not correct. And that's because it's incorrect. So I should rewrite it. Okay, so you got 50 altogether and you got X answered correctly. So there would have been 50 minus X, which were answered incorrectly. Right, now we can calculate the total marks that he got. Right? You know he scored 55 marks, so you got an equation. Right? You can calculate the total marks because there were X which were correct. Each correct one On the one hand, it was 55. On the other hand, you can calculate it. You got X correct, and each correct answer got 2 marks. So these questions here would have earned 2 X marks. But these remaining 50 minus X ones, right, you were penalized. 1 mark was subtracted for each one of them. So the total number of marks which were subtracted is 1 times 50 minus X. Because each time you give a wrong answer, you subtract 1 mark. So there it is. You got the equation. You calculated the total number of marks 2 different ways. 2x minus 50 plus x is 55. You change the sign when you go a negative sign outside the brackets. 2x minus 50. So that gives you 3x equals 105. Bring the 50 to the other side, and x is 35. And that is what we wanted. X was the number of questions to answer correctly, so he answered 35 questions correctly. You can check, he answered 35 questions correctly. So that would have given him 70 points, marks. And he would have answered 15 incorrectly. So he would have lost 15 marks because each incorrect ones. So you got positive 70 minus 15, and that gives you 55. So you can see that 35 is the correct answer. Okay, so now we go on to question 20. The answer to the last question was 35. Question 20, 3 different prime numbers, right? Okay, so we are talking about prime numbers now. What are the prime numbers? Let's just pause here. Prime numbers are 2, 3, 5, 7, 11, and so on. So 3 different prime numbers. So you got 3 prime numbers which are all different. Oh, you're giving them names A, B, and C. Each of them are smaller than 50. So they are chosen anywhere from 2 up to 50. The last prime number before 50, 50 is not a prime number. 49 is not a prime number, it's 7 times 7. 48 is not a prime number. 47, if you try to factorize 47, you won't get an answer. So this is prime. So you got all the way 2, 3 up to 47. Those are the primes that we're looking at. Now, if A plus B is odd and B plus C is even, what is the greatest possible value for A plus C? Right, now we are in the danger zone, 20 to 25, right? So you have to use a lot of logic here. Now listen very carefully. When you add A and B, the answer is odd. Now, when you add 2 numbers and the answer is odd, you can make a conclusion about the numbers. See, if you got 2 numbers, A and B, they could be even and even, or they can be odd and odd, or they can be odd and even. One of them is odd, one of them is even. Now, when you add 2 even numbers, you're going to get an even number. And when you add 2 odd numbers, you're going to get an even number again. Right? 3 plus 5 is 8. 5 plus 7 is 12. So the sum of 2 odd numbers is always even. But here they say that the sum is odd. So we are in this world here. So given A and B, one of them is odd and one of them is even. But we don't know which one is odd and which one is even. Right? All you can say is one of them is odd and one of them is even. Okay, now let's go to B plus C now. The sum there is even. So with B and C, you could have even, even, or odd, odd. Now comes the crunch. Amongst the prime numbers, very, very important fact, there is only one even prime number. Don't ever forget, very useful fact, even prime number, namely 2. Right. Any other even number can't be prime because you'll have like 14 is 2 times 7, 28 is 2 times 14. So if you can take 2 out as a factor, it can't very well be a prime number. But with 2, it is a prime number. 4 is not. So there's only one even prime number. Now you got the sum of 2 prime numbers is even. So this possibility here, if you are saying that both of them are even, it means that both of them will have to be 2. Because there's only one even prime number. But we are told that they are different. You see how the words become so important now, your question. See? You can't have both of them even because then there's only one even prime number. Then both of them will have to be 2, in which case these 2 prime numbers are equal, and that's not what we were told. So now you have to conclude B and C are both odd. Are both odd because the sum is even. All right. But we said here earlier, as far as A and B are concerned, one of them is odd and one of them is even. Now we are given that B is odd, see, and C is odd. So we can conclude that B is odd and one of them is even and A is even. One of them is odd, one of them, we know the B is odd, so A will have to be even. And that says, we know exactly what A is. A must be 2. It's a beautiful problem. Right? Just using these facts here, with pure logic, you can conclude that A must be 2. It'll be nice for you to go and try this thing out on your own. Look at this thing, reason the way I did, right? You heard it, and try to see whether you can conclude that A equals 2. Assume that you don't know that A equals 2, but by pure logic, A equals 2. So now the question is, what is the greatest possible value of A plus C? So you need to know largest value of A plus C. We know A is 2 now, and C is a prime. So in other words, you want to find the largest value of C. But remember that all the primes are less than 50, right? So to get the answer, to find the largest value of A plus 2 plus C, you want to know the largest, C will have to be the largest prime less than 50. You want it to be as large as possible. Largest prime number less than 50. Right? And it wasn't without any reason that I've said that 47 is the largest prime. You can see 48 is not, 49 is not, 50 is not. So 47 is this number that we're looking for. So 47 is a prime number. So this is 2 plus 47. So this answer to the question, the largest value of A plus C is 49. So C is 47. 2 plus 47 is 49. Okay, it's a very nice question. Pure logic. Logic, all you guys are, I'm sure you're pretty good in logic. You notice there's no mathematics here. I've got no equation, no x's and all that, trying to solve anything. We haven't solved any equation. Just by using the fact, the important fact is that the only even prime number is 2. Then we had other important facts, like the sum of two. If you know that the sum of two numbers is odd, then one of them is odd and one of them is even. Very important fact. Don't forget that. And the same way, if you know that the sum of two numbers is even, either both are even or both are odd. So those are some of the things that you learned from this last problem. Question 21, it says here that you got a 7-digit number. It's given there, a 7-digit number. There it is, 23A467B. It's divisible by 15. What does it mean? If it's divisible by 15, that means it's divisible by 5 as well as 3. So this number here, 23A467B, is divisible by 5 and also by 3. It's divisible by 15, you see. Okay, now just look at this first part. This number is divisible by 5. So your last digit, B. I was right about B, it looks like a 6. Didn't realize that. It's terrible. So B can only be 0 or 5. The last digit is either 5 or 0. It could be 0 as well. Now again, look at the question. What is the greatest possible difference between A and B? In other words, when I subtract these two numbers, I want that to be as large as possible. Right? So when I subtract A minus B, I want that to be as large as possible. To do that, it means that B must be small as possible and A must be large. That way I will have A minus B is as large as possible. Right? The difference, we are looking at the difference between A and B. So you want B to be as small as possible and A to be as large as possible. And therefore you will choose B to be 0. You wouldn't choose B to be 5. All right, so now I've got the value for B, and I got 2, 3, A, 4, 6, 7, and B is 0 now. Right? We made B equal to 0. Now, this is now divisible by 3. Let's look at the next fact. Now, you should know that for a number to be, for 3 to go exactly into it, the sum of the digits is a multiple of 3. So you got, add all these digits, 2 plus 3 plus A. I can go into the next page because I do have space. All right. Okay, so you've got, it's divisible by 3, and I'm going to go to the top here. So it means now that if I add all these things, 2, 3, 4, 6, 7, 0. You got 5 plus 4 is 9, 9 plus 6 is 15. You got 22, and plus A is unknown, right, is a multiple of 3. And remember, A is a digit. It's a one-digit number. It's one of the digits here, you see. Right? A digit is a one-digit number, 0 up to 9. And you want this difference to be as large as possible. So I told you, you want A to be very large. Right. On the one hand, you got two things. You got A to be the largest number, which makes 22 plus A to be a multiple of 3. You can choose 2. 22 plus 2 is 24. Okay, A equals 3 is possible. But that's, you can make that better. If you choose 5, 22 plus 5, that's also a multiple of 3. But if you go on, you can come to 8. 22 plus 8 is a multiple of 3. So that's as large as you can get. So therefore, A is equal to 8. And we already know that B is equal to 0. So the largest difference that's the question. The largest difference is 8 minus 0, which is 8. There are a lot of questions here about smallest and largest and so on, and we know what these words mean. So we just have to look at what they mean and try to solve the problem, understanding what the question is. Okay. Then we go on to the next problem. It's problem number 22. A shop owner buys an item for 60 rands and puts it on display in his shop. Right? When the customer buys the item, they are given a 20% discount on the marked price. If the shop owner wants to make a 20% profit on the item, what figure in rands should appear on the price tag? It looks like a very complicated problem. But if you break it down, all right, I'm going to use this page here, which I've got very much more. Same question. All right, so what goes on here? You've got this, there's some item, whatever it is. I'm not very good in drawing. Maybe some garment. And it puts it on display and it's put a tag on this thing. Right? He buys it. Buys it at 60 rands. 60 rands. Now, when the customer buys the item, they are given a 20% discount on the marked price. So this thing here is a marked price. This is the price which it is marked. The customer walks in, he sees that price there. And he's given a 20% discount, whatever it is, this thing here, right, is given, whatever that is, you work out 80% of that. And that is what he pays. And because you work out 20% of it and you subtract it from whatever it is, that's a discount, which is the same as saying is 80% of the market price. Right. Now, so this is what he pays. But we say, yeah, the shop owner wants to make a 20% profit on the item. He buys it at 60 and he wants to make a 20% profit, so he must increase. And here it's a decrease because it's a discount. So he's going to increase this item. He wants to make a profit of 20%. Very unusual. That is, these days people make at least a profit they make is 90%, 100%. 150%. People push up the prices enormously. It's quite frightening. Anyway, let's make a profit of 20%. So if you got 60 rands, right, and you make a profit of 20%, 20% of that is 1/5. 1/5 of 60 is, so what does he pay? So whatever he pays is going to be 60 plus 1/5. Because the shopkeeper wants to make a 20% profit. So he collects from this customer, he collects 72 rands. And now he knows that he's got his 20% profit. But now we know that this thing here represents 80% of the market price. So your question is, what thing appears on the tag? That's what I got here. What is this? So 80% of whatever there is equal to 72 rands. That's the point, right? After it takes away 20% from the market price, whatever it is marked at, evidently it must be much larger than 72, right? Here's the discount. So now, what is this market price? Let's call it M. So that's your equation. 80% of M is 80 over 100 times M equals 72. So M is equal to 72 times 100 divided by 80. Right? 80% of M of is times. So 72 times 100 divided by 80. And if you work this thing out, you don't have to multiply. The terms go into this, 8 goes into this 9 times. So it's 9 times 10. That gives you 90. It's 90 rands. So the market price is 90 rands. So the guy buys it for 60, marks it at 90, gives the discount. The person gets quite happy now. He's going to get 18 rands discount he gets because he sells it for 60. He pays 72 rands. Right? But the shop owner is quite happy. He's got his 20% profit. Okay, so that's the answer. Answer is 90 rands. Okay, so let's get on. Okay, so the next problem number 23. Problem number 23 says the following. If the following statement contains more than 50 fractions in total, so you got 1/5, 1/5. So the number of 1/5s here, and here too, you got number of 1/7s, they're ended. We don't know how many of these and how many of these, but you know that it contains more than 50 fractions. So altogether, you got more than 50 fractions here. What is the minimum number of fractions needed to make the statement true? And that's an interesting question, right? I'm going to go to the next page. So I have extra space. All right, so we have two unknowns here. We don't know how many 5s there are. Let's call it M. I like to use the symbols M and N when I got counting numbers, right? Then I know that I can't have fractions or square roots or something. I use M and N. I mean, if you want, you can use X. Sometimes I use X's, but I prefer using these numbers. Then I know in the back of my mind that it's a counting number. Okay, so we don't know how many 1/5 there are, how many this. And we also know that the total number, M plus N, the total number is greater than 50, right? Because it contains more than 50 fractions. And you want to know the smallest. M plus N, minimum number of fractions altogether. So that's the question. So it'll have to be some number which is bigger than 50, but which is the actual answer? Which is the smallest number you can put here? Right. Everything depends on this equation here. Now, m times 1/5 is m over 5, obviously. This is m times 1/5, right? And this is n times 1/7. So that equation can be written quite simply as m over 5 equals n over 7. You got only one equation. There are two unknowns. You don't have any other equation. So usually people get stumped here. They say, hey, I've got only one equation. I've got two unknowns. How can I solve this problem? See, the secret lies in the fact that m and n are positive integers, you see? Because you say there are m of these and n of these. You can't have 3.5 of one. You can only have 10 or 11 or 17. So m and n are positive integers. Now, what I can do here, from here, I can convert this to a fraction. Make it m over n equals 5 over 7. Right? The top over that equals that over that. But now I've got a fraction equal to 5 over 7. And there are many ways in which you can write a fraction. This is the simplest form. But there are many ways. You can make this thing 10 over 14, as we saw earlier on. Right? So we can try all these various things. You can put 10 over 14. But here the sum is 12. If m is 5 and n is this, we want m plus n to be greater than 50, you see. So now we are on our way, because we are going to try to find an m plus n must be bigger than 50 and the smallest one. So I can double this. Now this time I get a sum which is 24 and it's still 5 over 7. And if I multiply by 3, I'm still short because you got 36. If I multiply by 4, I'm still short, 20 over 28, right? But the next one, if you multiply by 5, you get 25 and 35. And that's the first one where you get m plus n is bigger than 50. See? So these are all equivalent fractions. M over n equals 5 over 7. All these are equal. So it's a very powerful statement. When you do equivalent fractions, right, in primary school, you know 10 over 14 is 5 over 7. You just cancel. But the other way around is just as important. 5 over 7 is 10 over 14, or any one of these. So there are many, many ways in which you can write 5 over 7, and you exploit that fact to answer this question. So you keep writing it until you come to m plus n is bigger than 50. So therefore, your m plus n, the first one, which is bigger than 50, is that one. And it must be 25 plus 35, which is 60. So that's the answer to this problem. The minimum number of fractions needed to make the statement true is m plus n, and that is 60. So go on to problem number 24. Okay, you got point O is at the center of both circles. The shaded area, this part here, is 1/3 the area of the larger circle, or the largest one. There are 3 circles, no, 2 circles, right? So this is 1/3 the area of the larger circle. And they tell you that the radius of the small circle is 1, you can see it here. And the radius of the large circle is 3, right? Remember, because you've got 2 and 1, So the full radius is 3. So you know the radius of the large circle, you know the radius of the small circle, but you don't know this slice, this pizza slice that we have. It makes an angle x. And the question is, if this shaded area is 1/3 the area of the area of the larger circle, what is x? All right, now this is a good example where you need to have equations because you need to solve for x. And so how do you create the equation? That is a challenge. Okay. So I've got this big diagram. I need to calculate areas now. Okay. You see, the thing is, this area here is a funny area here. It's not this area of a circle. It's not even the area of a piece of a circle. See? One important thing, the area of a piece of a circle, let's just talk about that for a moment. If I got a circle and I got a piece, suppose I got, and I know the angle. Suppose this angle I know is, say, 45. And I ask you, what is the ratio of the area of this pizza slice to the area of the entire circle? Right? A little bit of thought will tell you 45 here. So if you make all these 45, create several 45s. You get 8 of them. 2 45s is 90. So you got 8 exact areas because all of them are 45, 45, 45, right? So this area is 1/8 of the area of the circle. And if we see what we are doing, it's really 45 over 360. 45 over 360, that's the fraction of the area. Is the same as the fraction of this angle to 360, right? As you can see, because you just have to cut this pizza into the same equal parts, and you will see that they all have to be, all these angles are equal, all equal to 45, and each area has to be 1/8, because you've got 8 equal areas of the full circle. So if you've got x degrees, then we should be able to work out what the area of these pies are. So let's just call this small area A, and we call that area B there. Okay, A is this unshaded part here in between. So what is A? We just said now. Only thing is now I don't have 45 degrees, I've got x degrees. So I have to take x and put it over 360, as we did here. And that is x over 360 of the area of the circle. The area of the circle, we know what the area is because the radius is 1. So the area of the circle is pi times 1 squared, which is pi. So that is what A is. Right? Okay, so we still don't know what x is because we don't know what A is. Okay, let's have a look at B. Well, we don't know A, but we do know A plus B. We need to calculate B, right? The shaded part. But A plus B is this pizza piece, right? In other words, I'm adding all these guys here. That's A plus B. And for the same reason, you still got x inside. It will still be x over 360. But now the circle, the radius area of the circle is pi times radius squared. There, this is pi times 1 squared. But here you got 3 squared. So it's pi times 9. Right. So if you put this out nicely, you'll have, hey, this thing is going all tilted here. You guys can't see me. I'm left-handed. So we have a kind of a problem writing. Let me just make this thing. So it's A plus B equals. Right. If you simplify this, 9 goes into 60, 360, 40 times. So you have pi x over 40. And here you got pi x over 360. That's your A. So we got what A is, and we got what B is. So therefore, we can calculate B. A plus B. Right? When you add B and A together, you get this. So all you have to do is to take B away from A plus B, take it away from there. And that will give you the area of B. But we know that the area of B, the shaded area, is 1/3 the area of the larger circle. So there's your equation. And there's your equation. It's 1/3 the area of the larger circle. The larger circle is radius 3. So the area of that is 3 squared is 9. So pi r squared is 9 pi. Right. So there's you got an equation here, and we can 9 pi is 3 goes into 9 pi, so it's 3 pi. So if you try to solve this equation, the common denominator is 360. I can multiply by 360 right throughout, and I get 9 pi x minus pi x, multiplying by 360. And here you got 360 times 3 pi. Okay, 9 pi x minus pi x is 8 pi x equals 360 times 3 pi. That's 8 pi x. Pi's cancel. And there it is. We're getting our x now. 8x. 8x is 3 times 360. That's 8x. So x is that divided by 8. 8 goes into 360 45 times. We don't use calculators here. 8 goes into 360 45 times. So 45 times 3 is 135. So this angle here is 135 degrees. Your x was the angle. There it's 135 degrees. All right, so the important thing here is that the area of a piece of a circle can be calculated because it's just the same as the ratio of the angle to 360. It's very, very important. Okay, so that takes care. The answer to this problem is 135. And we now get to the last problem. Okay, so the last problem says, Mdu walks at a constant rate. It takes 72 seconds to walk up an escalator. Okay, I'm going to put the escalator as like a straight line, although it's not really, it's stepped. Okay, so it takes 72 seconds to walk up the escalator. Maybe we shouldn't do that. I want to use the steps. Okay, I'm going to draw it freehand. So it goes on like that. Now, when he walks up the escalator, now we're not worried about, here we're not concerned ourselves about how many miles per hour or how many kilometers per hour you take. Your measurement is how many steps he takes. And it's in seconds. So his speed you measure in steps per second. So we don't know what his speed is. So we'll say let him do speed be, say m, again it's a counting number. So I put m steps per second. So in 1 second, it covers m steps. But the escalator is actually moving. The escalator itself has got its own speed, right? The escalator also covers a certain number of steps per second. Those are the steps which disappear at the bottom, right? So we will let the escalator speed, it's got its own speed. Be, let's call it n steps per second. All right. Okay, so we know mdu's is m and the other is n. Let's get onto, I need more space. So now when he's climbing up, it says that it takes 72 seconds to walk up the escalator. Now, how do you interpret that? When he is walking up, he is going m steps up, right? But this guy is pushing him down right, by n steps. So what happens is that his actual speed, because in 1 second, n steps disappear behind him, and m steps is only moving up. So when this thing is going down, he actually is, the number of steps per second he takes m minus n steps. When you say speed, m steps, it means when the escalator is standing still, right? If he's not fighting the escalator, then it takes m steps per second. But now he's fighting it. So m minus n, we assume that m is greater than n, otherwise he'll fall down, right? He needs to get to the top and make sure that he goes faster than the escalator. Per second. And it takes 72 seconds to walk up the escalator. So therefore, escalator has got, in 1 second, it takes m minus n steps. So the escalator has actually got 72 into m minus n steps. Because it takes him so many seconds to get right to the top, 72 seconds. So the escalator, he has to climb up that escalator. Now, when it is moving downwards, he's going faster now. When he's moving downwards, the speed of the escalator is helping him. So his downward speed is really m plus n. Right? And this time it takes 36 seconds to go from top to bottom. Right? And again, this gives you the number of steps in the escalator. So these, now you got an equation. So 36 into this, m plus n, is equal to 72 into m minus n. Because in both cases, this is the number of steps, right? It takes 36 seconds to climb up the escalator or come down the escalator. So the total number of steps it covers is 36 into m plus n. All right, now you got an equation. The 36 cancels. Let's just go down here. What I can do is just erase this thing. Okay, let's try to simplify this. You got m plus n divided by 36 is 2 into m minus n. That is 2m minus 2n. So you can bring all the m's to one side, or 3n, 2n plus n. Let's destroy all the negative signs, and it's 2m minus n. So you got m is equal to 3n. Right. So the question is now, how many seconds would it take him to walk up or down if the escalator is switched off? So now he's not fighting the escalator, right? So it covers m steps per second. And we know that the total number of steps that the escalator has got is 72 into m minus n. This is the total number of steps he has to climb up. He's taking m steps per second, and you want to know how long it will take. So you have to divide, because you got so many steps altogether, and you can do in 1 second, you can do m steps. If you want to see the time it takes, you just have to divide. But we know that m is equal to 3n. M is 3n. So I can substitute m equals 3n here. M equals 3n. And very nicely you have 72 times this, 72 times 2n is 144n. And you got 3n at the bottom. The n's cancel. 3 goes in 144, 48. So the answer is 48 seconds. See, some of you would have guessed, you'll say, well, it's 36 plus 72, and take the average of that, and that is 54, and that'll be the answer. But the answer is not 54, it's 48. That's because you've got different speeds. You've got m plus n, you've got m minus n, and so on. Okay, so the answer to this problem is 48 seconds. Okay, and that, guys, brings us to the end of this paper. Okay, I want to thank you guys for coming. Let me just see what's happening in the chat column. I'm going to stop share now. Okay, so let me see all the people who are in my class here. I don't recognize most of the people. So many of you did not attend my classes, but you might have been looking at my YouTube presentations, hopefully, right? In which case you would have learned quite a lot. Okay, I just recognize some of the names here. Okay, now let me just see if there are any questions in the chat column. Okay, so somebody asked a question, the digits themselves are less than 50. Yeah, it's not the digits, it's the total number of fractions which is less than 50. Oh, I skipped question 10. Oh, yes, it did. Okay, C equals 43. Right, you saw C is 47. That's the largest prime number less than 50. And so there are some people are making comments here. Hopefully you've answered your own questions. So that problem with the primes seem to have given people a lot of headache. I don't know what's going on here. I adopted somebody else's hand. Okay, I think that's the last one. I don't know what NVM stands for. Or maybe never mind. Now, are there any questions? Any other questions that you have? Now, yes, who was that? Ivan?
No.
Yeah. Oh, okay. Ask the question.
What's the answer to question 10?
Oh, question 10, eh? Yeah, we didn't do this. Let me just go. I missed that one. Sorry about that. Oh, this one. Sonia, right. Okay. Okay. Well, in this problem here, I need to share. But you can see it. All right. A man spends quarter of his money in his wallet. So he's got a certain amount of money in his wallet, and he spends a quarter of that. He then gives a third of the remaining money to his children, and he's left with 200 rands. So basically, at the end, he's got 200 rands. This was after he gave a third of his money to his children, right? So in other words, just before that, right, he gave a third of his money to his children. So how much must he have had here? Right? You take away a third of this thing, and you're left with 200. In other words, this thing here represents 2/3 of his money because he's taken away of this question mark. So if this represents 2/3 of that amount, then this would have been 300. See, you can do this mentally. 2/3 of 300 is 200. So before he gave his money to his children, he had 300. But then before that, he spent a quarter of the money in his wallet, right? He had something in his wallet here, and he spent a quarter of that. So he was left with only 3/4 of whatever he spent. So this thing here is 3/4 of the initial money. So if 300 represents 3/4 of the initial money, then you can see even mentally, you would have had to had 400. So this is 3/4. Otherwise, a quarter of 400 is 100. You take it away, you get 300. The other way of doing it is 3/4 of x equals 300. Whatever x is. If you don't know it, then you'll say x is equal to, you solve for that, it's 4 times 300 divided by 3, multiplied by 4 divided by 3. You'll still come back to 4 times 100, which is 400. But as I said, you can actually, this problem you can actually do it mentally, because you want 2/3 to be 200, 3/4 to be. So the answer to the question is 400. Okay. All right. So that's question 10. Let me now come back to, I just want to see how many of you guys, I need to ask a question. Now you know all the answers. I don't know whether you remember what you wrote, but how many of you think you got over 20 out of 25? Nikita, you think you got over 20 out of 25? You got your hands up. No one? You can use your indicator at the bottom, which shows a symbol with a hand in it or something. All right. But anyway, it was, you got 25 questions, so it's very unlikely that people will get so many. But I'm sure many of you got 15 or more. Okay, whatever it is, all thumbs. Let's see whether some of you are in the top 100. Okay. Those of you, if you want to leave, you're quite free to leave. And if there are some people who still want to remain behind to answer the question, I'll be quite willing to answer the question.